This is question 2, and question 2 is saying, given that an array has n elements, what is the index of the second last element in that array? So the short answer is n minus 2, but let me demonstrate with code how I come to n minus 2. So I'm going to create a simple class called array to demonstrate this. So I have my class called array. Let me create a main method where I'm going to execute my code. And in Java, to create an array, you declare it like this. So you have these brackets, and this is how you define an array. And in this case, it's of type int, this data type, then followed by the variable name for the array. Then you follow this by saying new int, and then you terminate. So you can either specify the size of the array within the brackets like that, or 3, whichever number you want, because arrays have a fixed size. So when you're declaring it like this, you must give it a fixed size. Or in this case, I'm going to use curly brackets to define my elements in that array. And in this case, this is allowed because the compiler will know at compile time the exact size of the array. In this case, it will be 1, 2, 3, 4, 5, because there are 5 elements in that array. So you can either do it like this, or you can do it like this, 5 elements like that, and then you go down here and define the elements one by one like this, 5 like this, simple array like that, and so on until you reach the fifth array, the fifth element, in this case, which is 4, and it will be 1 like that, because arrays start at 0. So by the time you reach the fifth element, the index is 4, not 5. So let me go back to, or maybe let me leave it like this just to simplify the explanation for you guys. So this is 3, simple array, 1, 3, 2. So here we have n as equal to 5, which is the number of elements in the array. Number of elements. So the question is saying, for a given number of elements n, what is the index of the second last element? So in our case, our second last element is 2, and its index is 3. So how did I know that it is n minus 2? Because in this case, n minus 2 will be n is 5 minus 2, which gives us 3. So the index is 3, as you see here, the index of the second last element. So it is n minus 2 because in Java, arrays start start from 0. So if you want to get the last element in an array, that will be n minus 1 to get the last element of the array. So the last element in this case will be 5 minus 1, which gives us index 4, which is the last index here, and it will give us the last element of the array. So it's always like this. You have to deduct the indices, because the indices start from 0. But if the indices in an array started from 1, then the last element, of course, would be 5. Like it would be 2, 3, 4. So to get the last element, you'll just say 5 like that to get this one. To get the second last element would be 4, and then you get to the value 2. But in Java and in many languages, arrays start from 0, so you can't do what we've just done. It has to be like this, all the way to n minus 1, which is 4. So the second last element becomes n minus 2, which gives us index 3, and index 3 yields the number 2. So when you're answering, it is just as simple as saying n minus 2, because doing this demonstrates that you know that arrays start from 0, and to get the second last element, you have to subtract minus 2 to get that index. So it will be as simple as that. Let's do part B. Using an example of your choice in Java, demonstrate the concept of array of objects. Your program should capture input from the user, so we must use the scanner here to capture input from the user at runtime for 3 objects. So we need to create an array that can hold 3 objects, an array of objects that can hold 3 objects, and print them on the screen. So let me demonstrate this using a simple class called person. And person has a name, so string name. Then let's create a main method. So we need to create an array of objects. So this array of objects is going to be of type person. The data type comes first, and in this case, our data type is of type person. And then to make it an array, we use the brackets. Then we give it a simple variable name like person. And then we say new person like that. So this is how we created the array before. In the other previous example, if you can see the similarity here, you have the data type, the brackets to make it an array. Then you have a variable name, and then you initialize it like this using the new keyword. So same thing we have here. It's just that the data type is now person instead of int, because classes are custom data types. And we have a class here called person. So person is an array, and the variable name for our array is person, and it is initialized like this. But now the size they want is 3, which gets rid of the error there. So we already have a person array that holds 3 people, 3 objects. So in memory, this looks like, not just imagine, not in memory, but just imagine something like you have your first object here, you have your second object, and your third object. Like that is the array array of objects, the array of 3 objects, and these objects are all people because our class is of type person. So the next thing we have to do is capture the name of this person and then print it out. So to capture the name of the person, you're going to use the scanner class, and once you type scanner, you can see it's from the package java.util. Once you type the scanner class like this, for my IDE, it automatically imports the scanner class from the java.util package. But when you are in an exam, the moment you type scanner, you write scanner like this, you must go up here in the paper above the class declaration and type this import. So to make sure you get these marks as well, because you must have this import for this class to work. So the scanner is going to call scanner, and I'm going to initialize it like this. System.in. So I'm going to use the methods on the scanner class to pick user input for this person. So to do this, I'm going to say the person's name. Okay. I'm going to say person. First, I have to initialize the person class. What's happening? Require type person array provided person class. Okay. So, okay. So I'm going to say, remember when we said this is an array and it contains objects like this. So I want to initialize and reference this first object here. So I'm going to say my first object, this first guy here, my first person, which is this guy, is equal to a new person like this. If I wanted to use the second one, I would say person1, because remember arrays start from 0. So this is 0, this is 1, this is 2. So the first person is going to be equal to a new person, and then this first person, the name for that person is going to be whatever you're going to get from the scanner class using the next line methods, like that. So meaning we can then prompt the user to enter a name like that. But this is just for the first person. So if I wanted for the other people, the other 2 objects, I'd have to copy this and paste it 2 times. So you can see it's already looking very ugly. So we can solve this because then it will be the second person like this. And then, this is 2, like that. So it would be like this, but we are repeating ourselves somehow. And the rule of thumb is do not repeat yourself if you can anyway. And in our case here, we can avoid the repetition by using a for loop. So we can get rid of these lines, copy this, create a for loop that starts from 0. Int I is 0, I is less than the size of our array, which is person.length, and it's going to be incremented by 1 each time. And then we can paste this code of ours. Now, when this runs in a for loop, it will be running only for the first person. So it will run 3 times for the first person, and we want it to run for all these objects. So to do that, instead of hard coding the 0, we have to use this variable I, which will be incremented by 1 each time. So at first it will be 0, then it will be 1, then it will be 2. So it will go from 0 to 1 to 2, like that. So let's run this and see how it works before we proceed. So it has already executed this line, and now we are on this line where we are prompting the user to enter their name. So my first name is going to be John. Then it iterates for the second object. My person is going to be Elvis. And then my third will be Dan. And then the program finishes. So what they want us to do next? They want us to print this name. And okay, you have to print the objects on the screen. So after capturing the input, which are the names, we need to print them on the screen. So how can we do this? We can do this using this line of code. So to print an array, I'm just going to print it like this at first. Then we see what happens. Interface already complaining. Okay. Let's run it. We see what happens. So this line of code is supposed to print out whatever is contained in this array. So if my first name is John, second Terry, and third Dan, we get this weird looking string of characters. So this is because our person class does not have a toString method. So we need to override the toString method for our person class. It's going to return a string. It is called toString, takes nothing, and returns, we want to return the name, this name here. And this is an overriding method, so it is best practice to use the override annotation like that. So if I run this again, we should get the array printed out in a string format with the names. So we have John, Terry, and Dan. Okay, so we still get this string, weird looking stringy character. So okay, so this is because to print out an array of objects like this, we need to use the method on the arrays class, this arrays class in the util package. And once you type this, of course, then you have to go up here and import the arrays class from the Java util package. So arrays dot to string is what we want, and we need to print out the person array like this. So IntelliJ automatically imported the util package for me, the arrays class for me from the util package, and we are going to use the the string method on this arrays class to print out our person array, this array of objects of ours. So let's run this one more time, and we should get the names listed out nicely in an array. So the first is John, Terry, and Dan. Then we get the array printed out like this: John, Terry, and Dan. Okay, so this is part B of the question. Part C is asking us to use the concept of two-dimensional arrays to determine the determinant of any 2x2 matrices using the two-dimensional, okay, using arrays. User input at runtime is required. So you must use a scanner here. But once you see user input, just know a scanner is required. Note, if a matrix A is equal to this, determinant of A is that. So they've given us the formula for getting the determinant. So we need to create a matrix using arrays, two-dimensional arrays, and we have to make them look like this. Okay. So let me create a third class called matrix, and this class is going to contain our two-dimensional array. Remember, that has to be in the main method because the code is going to run in the main method. Now, to create a two-dimensional array, this is the syntax. They are going to be integers because we have ints here. So 4, 3, 5, 6, these are integers. So this is a two-dimensional array like this. Two pairs, a pair of brackets. Two pairs of brackets like this. And then the data type, which is an int. And this is going to be a variable called matrix. So our two-dimensional array is called the matrix. And we initialize it the same way we initialize the previous ones, like that. And remember, arrays are fixed size, so we need to fill these brackets with the sizes. And what do they want? They want a 2 by 2. So 2 by 2, 2 by 2 array, two-dimensional array. So what next? They want the determinant. Okay. So we are going to use these values here, 4, 3, 5, 6. And how are we going to arrange them in this order? Now here, the best way for me is to think of these as coordinates. Remember, in mathematics, when we're plotting graphs, we use coordinates of x and y. So like x and y, these kind of coordinates. So I'm going to use positions like this. The first value of x is 0, and the first value of y is 0. So this will hold this first value here, 4. And then we have the second value. Here x is incremented by 1, so x is 1 on that axis, and y is still 0 on that axis. But when you go down, y then becomes 1, okay, -1, but see it as 1. Then we have x here being 0 still. Then y is 1 because we have gone down 1 level. Then when you move to your right, x is then 1 and y is also 1. So we have our matrix like this. and these positions here 4, 3, 5, 6 are going to be, this is going to be 4, our value 4, this is going to be our value 3, this will be our value 5, and this will be 6. So let me write it here, 4, 3, 5, and 6, like that. That's going to be our matrix. Now, how are we going to get here? We're going to get here using a for loop. And we are going to start with x being 0. X is going to be less than 2 because we are going to have 0 up to x value of 1. So we're going to have 0, then we shall increment until x is less than 2, which is 1. And then x is going to be incremented by 1 each time. Now we are going to have x here, and we are also going to have y. So we are going to, in essence, have 2 loops. So while we are looping x, we should also be looping y. And we can achieve that using an inner loop. And this inner loop is going to be y, which will start from 0 because the first position of y is going to be 0. And y is going to be less than, what's the last value of y? 1. So y is going to be less than 2. And y is going to be incremented by 1 each time, like that. And then the final line of code will be to compute or to express this coordinate here, like this. And we are going to do that using the variable here, the matrix, like this, matrix with first value x and second value y is going to be whatever whatever we can get from the scanner. Now, we haven't defined the scanner yet, so we should do it up here. And the method to pick integers from the keyboard on the scanner object is called nextInt, like this, nextInt with capital I here. So let's define a scanner class. Remember that once you type scanner, you must import the scanner class from the util package. Our scanner here is called scanner, and is equal to new scanner. Our source is system.in, like that. Now, next thing to do is to test if this actually works, if we can pick these integers from the keyboard. So let's do that. Okay, so there's no prompt here you're seeing to prompt the user to input the values. So let's just type 4, 3, 5, 6, like that, and then the program ends. So we can pick the values from the keyboard. So let's prompt the user here to enter a value, like that. So how do we know that 4 is actually this coordinate here and 6 is actually this one? Because we need to know where they are positioned in the array. So we can do that using, two ways. So let me do the more manual way of doing it. So we can access our matrix above and hard code the values like this. And then we need to print this out. So print this. And then you have to do this 3 more times to get the other values. So this is 1, 0, this is 0, 1, and 1, 1. So let's run this again. And whatever value we input here should correspond to that to these variables. So our first value is going to be 4, 3, 5, 6. So here you can see when we are printing out the values contained within the matrix, 0, 0 is corresponding to 4. 0, 0 is 4. 1, 0, which is this, is 5. Eh? Huh. Okay. 1, 0 is 5. X. Oh. Okay. Yeah. Huh? Yeah. That's how it's supposed to be. Oh, okay. 4, 3, 5, 6. 4, 3, 5, 6. So this is 0, 0. Then 1, 0. 1, 0 is 3. Then we come down. 0, 1. 0, 1 is 5. Then 1, 1. So 1, 0 is not 3, it's 5. 1, 0, 1 is interesting. Okay. So the value contained in 0, 1 is 3, and the value in yeah, and the value in 1, 1 is 6. Okay, this is interesting. 4, 3, 5, 6. 4, 5, 3, 6. 4, 3, 5, 6. Okay. 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 I thought we'll have 3 here, then we'll have 5 here. But it's kind of fine, since when we are calculating this determinant here, the determinant is going to be basically the product of this diagonal here minus the product of this diagonal. So it doesn't make a difference where 5 and 3 are positioned, because they're going to multiply them either way. So then let's switch this to 3 and switch this to 5. So this is one way of doing it. The other way is to use the arrays class, like this arrays class, and this arrays class has a method called deep to string, like this. So deep to string the matrix. Give me so dig down into this matrix, basically, because deep dig down into this matrix and give me the string representation of this matrix here. So when we run this again, 4, 5, 3, 6. So we get 4, 5. We get an array, this outer array, an array of arrays, which is what two-dimensional arrays is all about. Is that a two-dimensional array is an array of arrays. So we have arrays inside an array. And then the first array is 4, 5, which is this. It's this one, 4, 5. Then the second one is 3, 6. This second array, 3, 6. So we have confirmed we have the values and they're in the correct positions. So what next? Next we find the determinant of this matrix. And to do that, we have to multiply 4 by 6 minus 3 by 5. So we are using these same values here. So determinant of A is 4 by 6 minus 5 by 3. So this will give us 6 times 4 is 24, 5 times 3 is 15. What's 24 minus 15? 9. So we should get determinant 9 as our final answer. So let's calculate our determinants, and we are going to do that using a method declared outside the main class, the main method, public. It's going to return an integer, and we're going to call it determinant. It's going to take a two-dimensional array like this, and this two-dimensional array is going to be called ARR, and here it's bringing an error because we must return an integer, and what we are going to return is going to be the actual determinant of this array here, whatever array we shall pass as our argument. So our two-dimensional array will be that should give us the determinant like wait, oh yes, like this, because we need to calculate this times this. So array at position 0, I mean rather value at position 0, 0, this, minus the value at position 1, 1, or not minus, times like this, times the value at position 1, 1. Then to make this proper, follow some mathematics, board mass. Let's do it like this. Then minus this here, this diagonal here. And that diagonal is array of this is the value 0, 1 minus the value at position 1, 0, like that. So that's our determinant, and it is returning this calculation here. This is times like that. Now we no longer need to print this out, but what we need is an integer called determinant, which will hold whatever value that comes from the determinant method, which is not working. Okay, it's not working because this is an instance method. This one here is an instance method, and instance methods require that you call them using an object. So an object of type class, of type matrix, like this. Matrix is equal to new matrix, like that. And then we can say matrix 1, like that, determinant, because of that, like this. Then we pass in the determinant, the two-dimensional array, which is matrix, like this. Or the way I like to do it is not to call an object, but rather to use this method as a static method. So basically public static, like this. So we have to declare it as a static method, so we can use it without calling it on the object of type matrix. So that's another way of calling methods. You can make them static like this, so you can just call them without first initializing an object. And then we can print out our determinant. this equals whatever we are going to get from that method call. This method call, remember, this method call returns an integer. This return here is going to be an integer because we are going to be multiplying integer values here and subtracting from integer values. So whatever is returned from this method is put into this value, this variable name here, which is later pointed out like this. So remember, from our formula here, we should get the value 9. So when I run this again and input my values, first value is going to be 4, second 5, third value is 3, and the last one is 6. And then we get a determinant of value 9. So that's part C.